Number 1, in 2017, Cornwall Central High School had 1,075 students enrolled. Of these students, 352 participated in the music program and 419 participated in the athletic program. The probability of randomly selecting a student who was either in music or athletics is 668 over 1,075. So this is an or probability here, either music or athletics. Find the probability that a student participates in both programs. So I'm going to do this problem in two different ways. First, I'm going to do it with a Venn diagram. Now, normally when we do Venn diagrams, we do probabilities, but this is not a nice probability to be using, so I'm going to do it with counts instead. So we have a music program, and we have an athletic program. So music has, that circle needs to have 352, that entire circle. That entire circle needs to have 419. And that OR probability, remember an OR probability is both of the circles and the overlap. So the two crescents and the overlap. That represents that OR probability. So if we think about it, together those two circles need to add up to 668, well, those three pieces. If I add those up right now, I'm at 352 plus 419. That gives me 771. So if I add them together, that gives me 771. But I can only have 668, so let's subtract that away to see what the overlap is, to see what my extra is. 103. So there's 103. Oops, I moved the circles there. There's 103 that go in the middle. So we don't even need to finish filling in the circle, because find the probability that a student participates in both. Well, the probability of music and athletics is 103 out of, well, how many kids are there? 1,075. That's the probability of music and athletics. Now you could use the OR formula, which is kind of what we did here without really using the formula. We saw in class that the P of I'm going to use music and athletics. So the probability of music or athletics, union athletics, well, it's the P of M plus the P of A. So add those two circles together, but subtract the middleman because you counted it twice. So subtract the intersection. But again, why am I going to do this with probabilities? That's just going to be a mess with fractions. So if I just do the counts, the number of them instead, that gives me 668 equals music is 352, athletics is 419, minus the intersection. So if we add that up, we get 668 equals 771 minus x. And I subtract that 771 over, I get negative 103 equals negative x. So there's 103 of them. But remember, 103 is not a probability. Probabilities have to be between 0 and 1. So what's the probability of music and athletics? Well, that probability is 103 out of 1,075. So either way that you did this, you were doing the same thing. One was just more of a visual representation. The other one was using that OR formula. Number 2, suppose there's a 50% chance of rain. So I'm going to stop right there. P of rain is 50%. A 60% chance of rain or lightning. Probability of rain or lightning is 60%. And a 15% chance of rain and lightning. So the probability of rain and lightning is 0.15. What is the probability that we will have lightning today? So I want to know what's P of L. So a couple ways to do this. You can jump right to the formula and plug and chug from there, but I'd rather just make a Venn diagram and go from that. So I have rain and lightning. I know the intersection's 0.15. All of that needs to be 50%, so I'm missing 35% in that circle. And that OR probability says that circle plus that crescent there has to give me 0.6. Well, I used up 0.5 of it, so there has to be 0.1 left over there. What's the probability of that entire circle? Because that's what P of L is. P of L is that entire circle. That entire circle there is 0.25. So the probability that it lightnings is 0.25. Are the events rain and lightning independent? There's two ways to do this. There are two ways to do this. We can look at P of R, which is 0.5. We can look at P of R. Remember, that probability is still the same, but this time we're going to say given lightning. We're going to say given that it lightninged out. So what's the P of R given L? Well, it's and over given. I know my universe shrunk down to the L circle, 0.25, and I want to know what's the probability of getting R, 0.15. If you compute that, you get 15 over 25 is 0.6. So, are they independent? No. You are going to write a sentence now saying, no, rain and lightning are not independent because P of R does not equal. Those two probabilities are not the same. Knowing that it's lightning, there was an increase of a probability of raining. So they are not independent because P of R does not equal P of R given L. The other way to do it is to use that product test where you multiply them together. You see P of R times P of L. So what's 0.5 times 0.25? So 0.5 times 0.25. That comes out to be 0.125. Well, what's the probability of the and? What's the and probability? What's the intersection? 0.15. Are those two equal? No. Therefore, they're not independent. Rain and lightning are not independent because P of R times P of L does not equal P of R intersect L. Either way you go, pick one and get good at it. Pick one and get good at it. Number 3, the results of a survey of the student body at Irondequoit High School about television viewing preferences are shown below. What is the probability a randomly selected student from Irondequoit High School will be female or prefer reality series? So I want P of female or reality. So, to find that OR probability, when I work with two-way tables, it's probably easier just to use that formula. Except we're going to do it with counts. We're going to do it with counts again, and then divide by the total. So, that's the probability of female, plus the probability of reality, but I need to take away the middleman. I need to take away their intersection. So how many females are there? There are, how many females? 260. Plus how many reality series? Reality series is, here's reality series. Total is 180 minus their intersection. Where's their overlap? Where are the female and realities? I counted those 110 twice. All over 490. Because I need to make it a probability. So out of the total. Because I'm randomly selecting them. So 260 plus 180. But I overcounted that by 110. So I get 330 out of 490 is that OR probability. OR probabilities are a little bit trickier with two-way tables. You have to be careful. Number 4, if P of A equals 2/10 and P of B equals 5/10, and A and B are independent, so I'm telling you right now that they are independent. What is that? The probability of A or B. So, I'm telling you they're independent. When two events are independent, we can multiply their probabilities together. We can multiply their probabilities. 0.2 times 0.5 is 0.1. And that equals, that's the and probability. That's the P of A and B. That's the overlap. When they are independent, you can multiply their probabilities together and get the intersection. So what's the probability of A or B? Well, the probability of A or B is going to be A plus B minus the overlap. So A plus B is 0.7 minus 0.1 gives me 0.6. So that OR probability is 0.6. Is it necessary that A and B are independent events? Explain when you use this condition. For this problem, it is. Otherwise, you wouldn't have been able to do it because you wouldn't have known about the intersection. Yes, knowing they were independent let us know that we could find the and probability. When did we use this condition? We used it right here. We used that condition. When did we use that condition? We used it to find the and probability. Because they were independent, we can multiply them together and get the and. Then we just use the little rule, A plus B minus the intersection. Number 5, in a survey of high school students, 85% said they like pizza, while 68% said they like hot dogs, and 61% reported they like both. What is the probability of randomly picking a student who does not like pizza and does not like hot dogs based on this survey? So, whenever I see that type of setup, I'm going to make a Venn diagram where we have pizza, we have hot dogs. Well, I'm not going to start with the 85 and 68 because that 85 is pizza overall. Hot dogs is 0.68 overall with 0.61 in the middle. So using subtraction, we can quickly find the people who like hot dogs but not pizza is 0.07, and the people who like pizza but don't like hot dogs is 0.24. Well, I want to know the probability that someone does not like pizza and does not like hot dogs. So the probability of not pizza means I can't be in the pizza circle, and not hot dogs means I can't be in the hot dog circle. So that means I need to be on the outside. I need to be in that rejected area where I'm not in either of the two circles. So the first thing that I should probably do is find what's the probability I'm in the circle. What's the OR probability? Well, the probability of pizza or hot dog, well, let's add those all up there. 0.24 plus 0.61 plus 0.7 is 0.92. 85 plus 7% gave me 92%. So 92% was used up in the circles, so who's not in the circles? A good old 0.82%. So the final answer is the probability of not pizza, the complement of pizza, and the complement of hot dogs, not hot dogs, is 8%. 0.08. Forgot my 0 there. Don't do that, because 0.8 is a very different number. That was lesson 7, and that ends our little unit on probability.